The nature of photons, a single wave property. The photon is often described as both a particle and a wave in quantum mechanics, creating what is known as the wave-particle duality. However, in ideal conditions, we can consider photons to exhibit only one property: they behave purely as waves. This understanding arises from the fact that photons, in a vacuum or in an environment without any external influence, travel without restrictions, displaying the full potential of wave-like behavior. 1. Photons in free space. In a perfect vacuum, photons are free from any interaction with matter. They do not experience any forces that could alter their nature. Their behavior is purely wave-like, traveling through space without any need for a medium to propagate. This freedom allows them to spread out, pass through slits simultaneously, and remain the same photon across vast distances. In essence, photons in free space are not subject to the restrictions of a medium, making their wave-like nature the default state. 2. Influence of the environment on photons. While photons may travel freely in a vacuum, their behavior changes when they interact with different media. The medium, whether it's air, glass, or a gravitational field, influences how photons propagate. The speed, direction, and even the wavelength of the photon can change based on the properties of the medium. This shift does not imply that photons inherently have dual properties, but rather that their behavior is dictated by the constraints and characteristics of the surrounding environment. 3. Ideal conditions for photon behavior. In an ideal environment, free of external constraints, photons behave purely as waves. They move in perfect harmony with the ideal space around them, free to exhibit their wave properties in full. This is the core of photon behavior, showing that, under ideal conditions, photons do not need to assume any other form. 4. The essence of photons. Therefore, photons, in their most natural and uninfluenced state, are wave-like entities. The duality described in quantum mechanics arises not from the intrinsic nature of photons, but from the effects of various environments acting upon them. It is the environment that forces the photon to display behaviors that may seem to imply dual properties, but in reality, photons in their purest form are defined by a singular property: wave behavior. Conclusion: one property, not two. In conclusion, photons, under ideal conditions, possess a singular property: wave-like behavior. The apparent duality of particles and waves arises only under specific conditions and due to external influences. Therefore, it is more accurate to consider photons as being inherently wave-like in their natural state. When they interact with a medium or an external field, their behavior may change, but this does not imply a fundamental shift in their nature. Photons are best understood as waves in a free state, and any deviation from this is the result of the environmental factors at play.